Okay, I have told you earlier that in choosing your scale, you should avoid the use of prime numbers. Prime numbers, these are those numbers that can be divided by itself and 1. What do I mean by avoiding them? Example, when you say 2 units to represent 3 cm, 5 cm, 7 cm, 11 cm. This cm you're choosing is very low. Avoid it by all means in your graph, because it will make your values to be in decimal places that are not necessary. So for you to plot a good graph, avoid using prime numbers in choosing your scale. Now, your graphs is always in this form, where this now in between any of these tick bars, you will see that there are 5 small boxes in between the tick lines. There are some other graph books that in between the 2 visible tick lines, there are 10 small boxes in between them. Now, this one that has 5 small boxes in between them is already in 1 cm, while the one that has 10 small boxes in between them is already in 2 cm. If that is the case, what do I do? What I want to get at this point is, at times we easily say 2 cm to represent 2 units to represent 2 cm. Let's say this is what we have: 2 units 2 cm. This will be 4 units 2 cm. Where this is 0.0, the origin. You now see that in between this 2 cm, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 small boxes, which makes up that. Now, if that is my first point of reference, what then will be the value of one of these small boxes? So that in case I have a line, by the time I plotted my graph and it passed a point like this, I will exactly know what my intercept is. If I know what a small box is, it will be easy for me to determine this point. So what I will do to know the value of my small box, I will take the number of units, which is 2, divided by 10, the number of the small boxes that is in that unit is representing, which is 10 units divided by 2 units divided by 10, which is 2 small boxes. The 10 is the number of boxes, of small boxes that makes up that Hughes scale I have chosen. And in that case, if I do this, I'm going to see that this will be equal to 0.1. And if it is 0.1, it means it's 0.1, 0.2, 0.3, 0.4, 0.5. I'm sorry, this will be 0.2. So that this is 0.2, 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, 2. So you see I've arrived at this point. 2 divided by the number of boxes is giving me 0.2, which is the number of boxes that I need. And with this, I have been able to get what I want. So by the time I'll draw this line, this straight line, by the time I draw this straight line and it gets to this point, it will be easy for me to say 0.2, 0.4, 0.6, 0.8, which is the intersection point, which means my intersect C is equal to 0.8. So with that, you've gotten the value of the intersect that was discussed earlier. So the beginning of your graph, what you do there determines how well you're going to be running on this graph. So you are advised to take note. Your scaling, I have taken 2, the number of small boxes in each. If the number of small boxes, let's say I use 1 cm, and I represent it to be 2, it means my small boxes will be 2 divided by 5. And 5 is the number of the small boxes. Whatever it gives to me becomes the value of one of my small box. So when anything happens to any of the small box, I'll be able to know what that small box is. If I have a value on my table to say it gives me, say something 2.5 something, I will then multiply the number of boxes. Let me say if this is 2, I know that 2 boxes gave me 2, 10 boxes gave me 2. How will I get the 3 or the 3.5 as the case may be? I will add then the number of the small boxes. I can, if this is 10 boxes, I can add 11th box, 12 box, which is the value for 0.1 or 0.2 as the case may be of each small box to give me what that will become. This is how we determine the number of the small box in a graph. Thank you.